Today I'll be talking about Transmission Control Protocol by Daniel Johnson. And what I wanted to do is I wanted to go ahead and start with the beginning of TCP, in which in 1973 there was a need for a system or a network to be made, and with all the available technology at the time, the development of a full-fledged system of all the internet working protocols was started for ARPANET. With the early development of the original model, which was TCP, the acronym which stood for was the Transmission Control Program, which was the only core protocol. The first version of this predecessor of modern TCP was written in 1973, then revised and formally documented in RFC 675. And Transmission Control Protocol is one of the most commonly used protocols in networking communications today. Normally when speaking of TCP, it's normally combined with IP, which is Internet Protocol. Most of the time you'll see TCP, IP combined in a suite. TCP's main directive is to make sure communication is achieved from the data that is sent from one point to the next point. TCP works in a collaboration with Internet Protocol, which tells where a device is that we need to communicate with, whereas TCP transports and ensures that data is delivered to the correct destination. And before we're able to send information to a certain device, TCP creates a connection between the source and its destination. And TCP takes data or information and breaks the information into packets to be sent. When the data is received, the information is reassembled from the packet at the place of destination. So basically what that kind of sums up to is that the information that you're about to send or requesting, it's basically put into a box or a packet, and then it's sent to another place where it's taken out of that package and then assembled into a picture so they can see what they're getting or see what is requested. And TCP IP uses the client-server model of communication, which a user or machine, a client is provided a service like sending a web page by another computer like a server in the network. And these are the layers of Transmission Control Protocol. This is how TCP works. And one of the layers that I wanted to speak today was the application layer. And the application layer provides applications with standardized data exchange. Its protocols include the Hypertext Transfer Protocol, which is HTTP. We've all seen that on a web page. Or the File Transfer Protocol, which we transfer files. And the Post Office Protocol 3, POP3. Simple Mail Transfer Protocol, which is SMTP. And Simple Network Management Protocol, which is known by the acronym SNMP. And the other layer that I want to speak of on this slide is the transport layer, which it makes sure that the communication link is kept while communicating from this end to the other end. And TCP handles communications between hosts and provides flow control, multiplexing, and reliability. The transport protocols include TCP and User Diagram Protocol, UDP, which is sometimes used instead of TCP for special purposes. And the other two layers that we'll be speaking about is the network layer, which is also called the internet layer. It deals with packets and connects independent networks to transport the packets across network boundaries. The network layer protocols are the IP and the Internet Control Message Protocol, which is ICMP, which is used for error reporting. And which the error reporting is basically when you go ahead and you send a message, and it may be like 2 or 3 messages, and the middle message isn't received. So the error reporting, it may go ahead and report that message and know that you need that other message put back into the system where you get that message. And the other layer is the physical layer, which it consists of protocols that operate only on a link. The network component that interconnects nodes or hosts in the network. The protocols in this layer include Ethernet for local area networks, LANs, and the address resolution protocol. So basically, you take TCP, and that's your transport. That's your set of rules, and then it's carried by the internet. All right, and this is the TCP model that I found, and it says how TCP/IP works. And if you look at the model, on the left side is the sender, and on the right side is the recipient. And the step 1 is the TCP protocol breaks data into packets. And then step 3, in between the sender and the recipient, you'll find the router, and the packets travel from the router to router over the internet according to the IP protocol. And then we move on to step 3, which the TCP protocol reassembles the packets into the original whole. So by looking at the model and by everything that I've explained in this protocol or the presentation, we see that the sender is trying to send something, and it's basically just like the mail. So what we do is we go ahead and get a letter or something like that, and then we put it in a packet, and then it goes from one place to another, just like any postal service or post office. It stops there, just like the router, as you see, and then it goes from here, it goes to there, and it finally goes to the destination that it receives the information to. And then before that it can receive all this information, all the steps have to be followed, the communication needs to be set up, and it goes through its layers, and then it's transferred through IP. And this is basically how you get your information from the internet. You request one page from a server, and then one is sent back to you. And this concludes my presentation for today. If you'd like to send me messages, or I'll happily accept them, and I'll answer them in a timely fashion. Thank you.